Hello, in this video we're going to do the initial software setup and testing. First we switch the monitor on and then the Raspberry Pi computer at the power outlet and then the Whisper receiver. And here the Raspberry Pi is booting up. And we verify that the power supply lights are on for the 12-volt power supply for the Whisper receiver, and that on the GPS interface box the light is flashing about once per second. And we'll just wait a few moments for the Raspberry Pi to boot up. So it will boot up and automatically log in as user Pi with password Raspberry into the desktop Windows system. Fine. So up here we have the icon for a terminal window. This is all Linux-like. And the first thing we have to do is to set up the network configuration. Sudo for super user, nano for the nano text editor, /etc/network/ interfaces. This is the file we will edit, and here we are. So on the ship the network connection may either be DHCP if you're using Wi-Fi, or perhaps a static IP address. So both of those are allowed. If you're using a static IP address, then you have to scroll down here where I have put in the placeholders with the hash at the start of the line to ensure that they are comments. So just uncomment the lines by removing the hashes and then inserting the IP address, the router address and the domain name servers that your computer person would give you. Scroll down further if you are using DHCP, and if you are using DHCP here you will need to add in your WPA SSID, the correct name there, and on the line below you will have to enter in the password for your DHCP router. And then once those edits have done, Control X, Y to accept those edits and return. We've not made any changes here. That's how you set up your internet or IP connection. And just to check, ifconfig then lists the internet. We're not using, the IP addresses. We're not using Ethernet hardwired. We're using wireless access, and here it is 192.168.0.39 is my current IP address. So that's all fine. The second thing to set up is the time and date with the network time server. So sudo nano for the text editor again, /etc/ntp.conf, and this is the NTP configuration file. So we scroll down here and there are currently listed 4 internet NTP servers. It may be more suitable for use on board a ship where internet access may not always be necessary, that you have a local NTP server, in which case you take out the comment, the hash at the start of this line at the bottom here, and then put in the IP address for your local NTP server. That may, for example, be synchronized to GPS. So Control X to exit. Then if you make any changes you'd have to put in Y and then return to accept the file name. Then you need to restart NTP, sudo service VICE, NTP restart. That restarts the NTP. Right. Having restarted the NTP server, we'll now check that everything is okay. So NTPQ -P, and then here we have coming up the list of the IP numbers at the moment that the Raspberry Pi is accessing for NTP, and the fact that they've been reached, and the delay in milliseconds, offset and jitter. So that to me looks all well. If these numbers are 0, then those servers are not being reached. So ideally then you would have in this list your local NTP server. So to check the hardware of the Whisper receiver, I'm going to unplug the 3.5mm jack plug from the receiver box here and plug in a simple earphone instead and have a listen. The signal level is very low into the earpiece. With the antenna connected as we have now, there is some noise. You may hear some low frequency tones which are not whisper signals within the bandwidth. The whisper signals themselves can be decoded 30 dB below the noise, and so it's unlikely that we'll be hearing them. But if there's a noise-like signal that isn't too loud, then all is probably well. We can then unscrew the antenna. There'll be some crackles as you do this. And then remove the antenna plug. The noise should go down substantially, and all I'm left with is a low buzz at harmonics of the AC power frequency. That's fine. All is well with the Whisper receiver. Now we will test out the USB sound card here and its connection into the Raspberry Pi to record the digital audio, and then we will test back the playback function of the Raspberry Pi of its audio through into the headphone. Thus checking that all that part is correct. So we'll start up ALSA Mixer to handle the sound card. Press F6 to select the USB audio device, then press F4 to set the level, and we'll take it up to 15. There we are, and then we will record a sample of audio using A record -VV space -FDAT space foo.wav as the file name. And that's recording now, so we're showing a level here of about 18%, so that's fine. We're nowhere near limiting. The level is set correctly. That should be enough. Control C to exit, and then to play back we use OMX player, OMX PLAYER space -O space local for the sound to come out of the Raspberry Pi jack plug, not the monitor, and then the file name foo.wav. Yeah, and the earphone, and that's fine. We're hearing the noise from the recorded file. So all is well with the USB sound card and the sound handling circuitry. Now we will check out the functioning of the GPS receiver over here by looking at the data using an utility on the Raspberry Pi. So a rather long line here, which is set out in the documentation: sudo gpsd space /dev /ttyusb0, which is the address of the serial port for the GPS, -f, and then /var /run /gpsd.sock So we have GPSD, the daemon running, and then an X window program, XGPS, to look at the data. So this brings up a sky view in this X Windows pane of the satellites being received by the GPS receiver. And so here we have exactly overhead. Satellites in green have a signal to noise ratio of over 34 decibels. Those between 25 and 30 are in yellow, and those below 25 are in red, generally on the periphery. And so that's all well. We're showing a 3D fix, and we're showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 satellites in all within view. So that's all fine.